Good morning, everyone. This is Matt Sexton with the Florida Department of Transportation's CAD office. Welcome to Custom Drainage Structures Pipe Concrete Jacket. This is part of the FDOT CAD office Hot Topics webinar series that we are presenting on Wednesday mornings. James Worley is going to be your presenter for today. He will start momentarily. I did want to let you know there's a Q&A dialogue in the GoToWebinar dialogue, for lack of a better term. You can enter your questions. If you have any questions into that Q&A dialogue, we will answer those as we go. If your question is not answered in real time, we'll take some time at the end of the webinar to answer the questions that we can answer. If we're unable to provide an answer during the webinar, we will be compiling the list of questions and answers into a PDF document, which we will post along with a recording of this webinar on our website. That will be located on our posted webinars page. If you navigate to our site, there's a little link on the right side that says posted webinars. That will be located under our posted webinars. So without any further ado, James, go ahead and take it away.
Good morning, everyone. My name is James Worley. I'm the FDOT CAD office drainage support person. And today we're going to be presenting the Custom Drainage Structure Series Pipe Concrete Jacket. In the future, I plan on making a few more of these so that we have specific to the structure type. So look forward to ones concerning the pond control structures and some of the other more common or more painful custom drainage structures that you'll have to do. So with all that said, let's start going. Now, this slide's going to tell you a lot about all the requirements for the cells. The cells we use in the drainage structures, most of them fall into the standard node category, which is inlets, manholes, any kind of structure that has a top and a bottom. Those all fall into the standard node designation, and that's because they go together in a specific way. Now, the specialty nodes, on the other hand, the MES, FES, end walls, basically end treatments and junctions that don't have contributing flow coming into them. I think about that as I say it, and it comes to mind that some of the junctions function like the end walls, and some of the junctions, say a manhole, would actually be part of the standard node designation. But the junctions I'm speaking of here are for like the use of the null node as a junction, and the new concept that I'm putting forth now for the concrete jackets. So the big thing about the specialty nodes like the end walls and FESs and the junctions, specifically these jackets, these specialty nodes will only use two cells. They use a 2D plan and a 3D bottom. And that's kind of odd because you'd think they would use a top, but because of the way the software is written, only a bottom without a top can exist with two elevation points, and that'll become relevant as we talk about this and as you see how these have to be put together. At the bottom of the slide, you'll see there's a list of all the different types of points that are necessary. The big ones that you need to make sure you notice when you're doing any modifications are the points on line style 4. Those will be in the 2D plan view cells, and they are the location point. That is where, when you point to a particular place in your file to place that cell, or to place that structure, I should say, it uses this particular point in the 2D cell to figure out where that is in real space. So that is a very important point. Other points that are extremely important, there is a line and point combination that are on line style 3. And these are the alignment points and alignment lines within your cells. Now those exist both in the 2D and the 3D cells. And what these do is kind of self-explanatory. The alignment point gives a reference so that you know, or the software knows, where to align the cells vertically with one another. And the alignment lines gives it the ability to know the rotation of that cell when they're placed or brought together as a single element. All right, and as I had said before, the last point, the elevation point, that is on line style 5. And those points, normally a cell would, and these are in 3D top and bottom cells, normally a cell only is allowed to have one of these. But if it is a specialty node, which means you'll only have a bottom cell to use, the cell you're using is allowed to have 2 of these elevation points placed within the cell for reference. And the highest one of those will be used for, quote, ground elevation, and the lowest will be used for invert elevation for that particular structure. All right. What happens when you place a drainage structure? Well, I've got the stuff for the standard node, but for this particular webinar, we're going to skip on down to the specialty node. When you place a structure, in other words, when you click in the 2D view and you give it the offset and station, or you just click on an element to locate it, however it's actually placed, the location point of the 2D cell is positioned at the exact XY coordinate that you click in or identify by keying. The alignment point of the 2D plan cell provides a horizontal position for the alignment point of the bottom 3D cell. Then the bottom 3D cell alignment line rotation is matched to the rotation alignment of the line in the 2D plan. Okay, so that means that, remember when I was telling you, you have to put those lines in to match rotation. This is where it happens. If those lines, say one of them is 90 degrees off the other in the original cell, what you're going to have is a rotated part or an offset part, depending on how it was drawn. Yeah. The uppermost elevation point in the 3D bottom cell in a specialty node is used to establish the location, the vertical location. And it's usually near the top of the cell. So as I was saying, that is used for, normally it would be ground elevation on, say, an FES or MES. But in this particular case, we're going to kind of use it to do basically nothing, because we're going to base everything off the lower elevation point, because it is used to establish the invert elevation for this structure we're placing. And we want that to match where the pipes are coming together. Okay. All right. I am asked this question repeatedly, why custom drainage features are needed. The reason for a new drainage structure definition is because there has been a variation of the structure that you're trying to place, which means if you have a top and bottom combination, you're going to have different feature definitions for every combination of top and bottom. You're going to have new feature definitions for every variation if you create something that is completely different from what is delivered with the software. The feature definition itself calls on specific feature symbologies, and those feature symbologies call to specific element templates. The element templates actually call to specific cells or to specific other information that is needed to be a part of a feature symbology. So basically, anytime you create a new cell in the process of making your custom drainage structure, when you have to modify one of our existing cells to get this done, that cell has to be included in the element templates that are available to you in the current drawing. So you have to, once you're finished with all the CAD work of actually creating your new structure or your new structure components, each and every one of those components needs to be included in the element templates within the current file you're in. Once you've got those element templates created, then you can go ahead and copy a functionally similar structure that's available in the feature symbologies currently in your file. Now, once you have those feature symbologies done, then you can go on up to the feature definition level and actually create your new feature definition with those new feature symbologies in much the same way that you just created the feature symbologies. You copy a functionally similar example from the delivered nodes or features that are available to you with our kit when it comes to you. And that will allow you to then use it in your files. The thing that I tell people to start out, if there's a similar structure in the delivered structure list, place it where you want the new thing that you're going to be using. If not, find some kind of delivered structure that is functionally similar. When I say functionally similar, I mean, if you're doing something that modifies an inlet, try to use an inlet to start out with in your modification. Like what I was giving the example earlier, the pond control structures. You'd want to use the inlet type that was the basis for your pond control structure, whether it's a C or a D or whatever. You make a copy of that one in the feature definition and the feature symbologies for that. You make copies of those in the current file and rename them to what your new structure combination is going to be represented by. All this to say, basically start out with something in your file that is similar to what you're wanting to make. Then you'll do the modifications to the cell. This is if you need to change the shape of a cell, keep up with what you need, because if you're building a control structure like what we were talking about just then, or you're building something completely custom like these jackets we're about to get into, You're going to need to make sure you go into the DR plan cell and the Drain 3D cell libraries to make your modifications, or make copies and make your modifications, because you have to have both a 2D and a 3D minimum. Now, if you're doing something that's going to be an existing or going to represent something existing that you're going through this much to draw, make sure you put a 2D version of it in the DR Plan underbar EX cell library. That's where all the 2D existing cells are kept. All right. When you've got all the cells made and you've made all the things, changes and everything that you need in the cell libraries, it's time to create element templates first. If you've created cells that didn't exist before, in the element templates, feature symbologies and feature definitions in your drainage work file. So at this point, I'm going to jump on in and start making the structures. This scenario that we're going to look at, the design calls for a proposed pipe to be connected to an existing pipe, as kind of you can see in this sketch I've got up. You can't do that. There's not a good functional way to do that without putting something between them that the pipes can connect to, and that leads to using things that aren't necessary for the drawing. A lot of people have been using existing manholes to do this. Using the custom structure we're about to design and make, I think is a better idea. It may be a little more intense than, oh, sorry, that jumped. It may be a little more intense than just using the existing manhole, but I think it will be something that we're going to probably look at fully adopting and putting in the software. So without any further ado, I'm going to try, as I may, to go into a drainage file. All right, here we go. Come on. All right, let's see here. It is still going at it. All right, while this is going, see if I can get this box open where I can see it. This is the wonders of live presentation. Oh boy, is there a, yes, maybe there is. Nope. I was hoping there was a dialogue waiting on me in the background, but there's not, unfortunately. It's just taking it a moment. All right, well, this is getting concerning. Okay. All right, well, nothing else works. Try again. I'm sure there's no one out there that has ever had to use that clear crash. All right. Looks like things are coming in. Yay. Now then, as I was saying, what we have here is a situation where we have existing and proposed attempting to be connected together. And there's no pipe or anything in here because there's no way to get a pipe to connect to another pipe. So what we're going to have to do is use a structure. As I said before, one of the things that you want to make sure you do is place something that's going to be similar to what you're looking at. All right, so since this is going to be, sorry, my mouse is jumping all over the place, so fun there too. This is going to be a junction. I'm just going to choose the first manhole here and just come out here in space about the middle of these two and place this structure. Relative to alignment, I'm going to use that. And all this for right now doesn't matter. I'm just trying to get it into the file so that I have something to modify. Okay, in 2D and 3D, you see its place there, and it's currently available for selection. Now, when I select in the 2D here, I can then bring up our properties window. And down here in the feature definition, I get to see the manhole type 7 bottom two-piece cover. It tells me the description and, of course, all the information about that particular structure. All right. So what I need to do is go out to the drain 3D file and open it. So first of all, I have to be looking for cells. Now, while we're waiting on this, I made a mistake. I should have closed that properties window before I changed files, because there's been a bit of proof that that slows things down. So if you have the chance to do it, it's probably best to exit that and save yourself just a little bit of time. Okay. What I'm going to do now is bring up the models in this file. All right. Now, since I'm dealing with 36-inch pipe, what I'm going to do is go down to an MES for 36-inch pipe, and you'll see the reason that I'm using that as my basis for the cell here in just a minute. "36-inch single pipe." Now, the reason that I'm using this for my basis is because it's already set up as a specialty structure. It already has the alignment line and point at the top. It already has the extra elevation point at the top. And basically it has all the points in place where they need to be for me to start making the modifications. So also choosing the size pipe that we're going to be creating a jacket for allows me to model the jacket around an actual pipe, so that I don't have to hand calculate wall thickness and all this other stuff that's needed for the point placement, the connection region placement, and all these other factors that come in while we're doing this modification. Okay, so first thing to do, make sure you always do this before you start making modifications, is to make a copy. And what I'm going to do here is rename it to concrete jacket 36, and then do away with our copy information here, and do this. And take off the unnecessary information. And say okay. And there's our new cell. And we are currently in it, so I can go ahead and start making modifications without worry of messing up anything that is in the set that is needed. So first thing I did was deleted the skirting, the excess concrete we don't need. Next thing I'm going to do, and you'll notice I jump from view to view to view doing this because certain things are just easier to do in certain views. So what I'm doing is selecting everything that's at this point right here, which gives me an elevation point. Oh, that's interesting. Okay, fun. I don't know what's going on there, but selected these things. And if you look at what I'm selecting, I'm actually grabbing a point and a shape. The point is the invert elevation point. The shape that I've got there, That is a connection region for your pipes, and you'll see how that becomes useful in just a few minutes. So I grab these guys. I go back up here to drawing. That's probably the one that's going to have all my tools. And I just want to move it. I snap to the back of that, move to the left, hit enter to lock my axis. And then I snap to the end of that line at the top, which allows me to put that in direct vertical alignment with those points and the base of that line on the top part of the pipe there. Okay, with that done, now I can make my first small modification. And I'm going to use this view to select because it's just easier to see. Then I'm going to use this view to do the actual movement. And what I'm going to do is move this over, lock, hit :6, which will do 6 inches, and click. Now that I've got that one set 6 inches off, what I'm going to do is make a copy of it. So I do the same thing, pick a spot in the air, doesn't matter, pull to the left, hit enter, so that no matter how far up or down or in any direction I might want to move, I can only move in the horizontal plane. And since I moved 6 inches that way, I want to do 1 foot off in this direction so that the two of them will be 6 inches offset from the center line of the connecting jacket. So, all right, now that we've got that done, everything is set up so that I can start doing the modeling of the actual jacket. First thing I'm going to need is I'm going to need a circle that represents the inside diameter of the jacket. Oh, hold on, made a mistake there, sorry. What I need to do is to smart match the concrete pipe. It doesn't matter where you do it, just get the proper level and information. Okay, so now that that's done, I can go back to what I was doing. Placing a circle on center, click, then use your enter key again to lock, and then just do a nearest on any point on the outside of the pipe. Boom. There's our first part. Now, we're going to take that and do another move, and we're going to grab it in this view, move to a side, hit enter to lock the plane, and then snap to the end of that line. And you'll see in the 3D, it's moved so that it's in alignment with these points in the base of that line. It's also in the middle of the two connection regions. So now I'm going to make sure, go ahead and select that and do properties, because I need to make sure that it is a whole element. No field 9, where are we at? There it is. Okay, it's a solid, but it is considered a whole. And if you haven't used this before, you have 2 types of solids there. You have whole and solid. And this is going to be the whole in our 3D element that we're creating. But for now, that is what we have. Now, what I want to look at this point, and you guys probably all know this by rote, and I don't as well. So what I'm going to look at is the actual standard that these come from. Now, this will tell me information like a concrete jacket on elliptical pipe is 6 inches. And a concrete jacket, it looks like here, is 3 inches above the lip of one of the pipes. But if you look at the design, that basically puts it at 6 inches. So what we'll be doing is offsetting that circle that we have so that it is equivalent to the outside of the jacket that we're going to be building. So it'll need to be offset 6 inches. Now down here we look, and the length of the jacket has to be 24 inches for 24-inch, or 24 inches for pipes 30 inches or larger. So we have a 36-inch pipe, so the length of our jacket should be 2 feet. All right, so now go back to our design file, and what we want to do is use the offset command and come here and do 6 inches and make a copy. And I'll just choose it in here and do that. And now we have a circle that is going to be our outer skin or outside surface of our new pipe jacket. Now we need to make sure to make that a solid. And now for the fun little tool that makes all this happen. Group hole. So hold on just a second, I had that selected. So let me go back and do this. And it asks me to identify an element, identify the second element, and there. And you've noticed that it disappeared from over here because that just did away with our hole element. So now what I'll do is just delete something we don't need at this point, which is this pipe. And you now see in this view the beginnings of our concrete jacket. Oh, fun. Okay, now to make this a little easier for this portion, I'm going to go to the modeling area and pick up solids and extrude. Set to 1 kilometer. No, I do not want that to happen. And what I'm going to do here is use active attributes. Do not make this parametric because that's not useful. And click here. And I thought there was a both directions, but there it is. Sorry, just didn't have it extended enough. Okay, and I'm going to take it from there and do it 1 foot away from that. And that should give us our pipe jacket. Now, one of the things you're going to notice is these are not aligned with anything on the pipe jacket. Well, that's because we want these lines, or this point and these shapes, to be where the invert of the pipe will be that's coming into this. So you leave it set there and you don't move it to this point so that you can connect pipes to it and they align properly. Okay, now another thing, let's go back to here and grab these guys. I want to make sure this is something that is stressed. Now let's see what the varies is. Okay, everything on this point is 0, and that's the way that should be. You'll notice things on the other point down here are mostly 0 except for the Z offset. And the Z offset on this particular one is below the one above, so it will be a negative. The one up here needs to always be at 0, 0, 0, X, Y, Z. And the starting of this line, where is our line? Come on now. Oh, that's not the line. This is the line. There we go. Now, the starting of the line is effectually at 0. This one measurement has a little tiny bit off, but it's not enough in this case to affect a whole lot. So, try to think what is the next step. Let's just go back into our other cell file, DR plan. Come on. Why won't it let me click on it? Sorry about that. Took a moment to get that done. All right, in this cell file, what we're going to do is look for curb inlet, gutter. Under bottoms, curb top 9, flared in section, bottoms. There we go. Let's just use the 3-foot manhole. That'll be fine. All right, select that. Well, quit. It won't double click and then it double clicks too much. Okay, copy a model. We're going to be copying this and we're going to be making this into our concrete jacket 36. Okay, and now we're in that cell, so here comes the fun. What we're going to do is basically delete all these parts that are in here and then just place a representation of the top view of that structure. So get that set and then just start deleting things. Do not delete the line or the points. Then we're going to place a block. That should, I believe, be 2 foot, and this should be 4 foot. If I'm thinking of it being placed, I thought I said centered. All right, that should be correct. But I think it needs to be rotated. So that orientation line was going out the back of the structure. So I'm going to do that, rotate 90 degrees, about the element center. Okay, so now if I've done this right, we ended up with 4 foot that way, 2 foot that way. So we now have a proper 2D representation of our new structure. All right, that means we can go back into our design file and create our element templates. So back to DGNs. Did it again. I forgot to do away with the properties window, but that is a habit that's hard to break, leaving those things open. Okay, now back in our file, and the first thing we're going to need to do is make our element templates. So we're going to go right here to our templates, go to manage, drop down our file here, drainage structures, junctions, plan. We have this that's in the file. So what we're going to do is make a copy. Paste our copy. Rename our copy. All right. And over here, we'll come in and we'll do this and call on the proper cell. These are supposed to be in alphabetical order. Plan view should have access to the 2D cell libraries, and I'm not seeing it. Did I make a mistake and put it in the wrong place? 36 underbar 3D. That's our 3D cell. Let me just exit here and come back in. Wait. Make sure that I did this correctly. I think we're running low on time. It's not what I need. All right, bring this up and look for okay, so it is named correctly and it is in the file. Oh, these are the things that you may run into when you're creating your custom drainage structures or doing any other operations that have to do with cells and files. Mm. Okay. Roads modeling. Home tab. Manage. All right. And there it is. Yep. All right, and next we go do the same thing to the 3D top. And select the correct cell. In this one, you have the option of going ahead and assigning a material just to make sure it's right. I'm going to just put concrete 1 on there at this point. You don't have to do that. You can do it on the actual feature, but just going ahead and doing it here won't hurt anything. All right, so that being done, we can exit here and go to our Explorer to start manipulating our feature symbology. Go into the file you're currently in, go to feature symbologies, go to point, node, stormwater node, junction, and make a copy of our friend here. That's right. This is the one that you do right click only. And then all right, and over here in the plan, the annotation group stays the same and the template needs to change. And there it is right there, concrete jacket 36, plan view. All right, and we're gonna go ahead and tell it where the 3D is here as well. And now your feature symbology for your point portion of the node is ready. Now we're going to go to the solid feature symbology and stormwater, junction, manhole, and right click, copy. All right, this is the solid, so it's a 3D, and we come over here and our top template. Yeah, we don't have one of those. We turn that to none. Then the bottom template, we change. Oh, come on. There we go. All right, so now that is assigned to the 3D that we had. So we are ready to go on to our feature definition. That's different. Node, stormwater node, drainage structures, junction. Do this. Boy, that was different. Copy. All right, it made our copy and did a bunch of other stuff too there, but go ahead and rename this. All right, and then over here, we need to give it the point feature symbology we just created. And down here, we need to give it the solid feature symbology we just created. Now that it's pointing to those, it's renamed. We need to give it a better description. All right. And with that done, we should have a feature definition to utilize. Now we go back to the structure on the screen. Go to the feature. And change to the new feature definition. Thinking about it. I hope everyone has enjoyed this and has gotten some information out of it that's useful. One thing you always remember is I'm here to help. So please don't hesitate to call. I'm going to rotate this to what looks like the correct rotation. And then with that, I should be able to connect existing and proposed. Now here is our proposed. So let's go to layout, place conduit. Well, since it's already set to existing, I'm going to go ahead and do the existing pipe first. You'd actually be doing the other way around. You'll notice that there are those little tiny dots right above that X and right above the X there. And that's going to give you the ability to, no matter where you touch on the structure, on this side, it's going to connect there. If you touch this side, it's going to connect there. So with that, boom, and all the way down to our existing structure. And there's our existing line in place. And now I can come over here and go to circular concrete. Oh, how did it change? Circular concrete, 36-inch pipe. And I'm going to just do the 105 for this one and go from our proposed to our jacket. You see it connected up pretty as can be right there in the 3D without any problems. Your 2D, you see that it also connected up. No fuss, no muss. That is the conclusion of this. Well, hold on. Let me say one more thing. This node can be moved up and down by utilizing invert of the node. Let me see. Is it going to tell me that information off of this? See, it's telling me that it's locked to the ground elevation because elevation reference right here is set to a thing. And I think I actually have to slope of surface, vertical offset, utility properties. That's how that's done. Desired sump label. Oh, this has gotten much bigger. Set rim to ground elevation, false. And at that point, you should be able to modify your elevation. Or hold on, elevation reference existing ground circular. So, invert circular structure faults. I don't see another setting that I can pull. So we're gonna go okay with that. And it's still got it grayed out. It shouldn't have that grayed out. Okay, there we go. I just removed that reference. So now you can actually move it by either of these values. So if we took the invert elevation down to 26, down that goes. And here's the point I wanted to make. Your pipes are not always going to follow. So you may have to reconnect them. Easy enough. Or you may have to set the individual pipe depth. But either one will work. Well, if you select the right thing. It's not difficult. It just takes a little bit of work. There it is. All right, so now we have successfully completed this scenario. And with that, thank you for attending. We've kind of gone over time, so what I'll do is get a list of the questions and try to answer all of them to the email that is supplied with the sign-on for the event. Matt, if you'd like to take us out, anything else that I might have forgotten?
No, that was a fantastic presentation. I do want to thank all of you for attending and spending your morning with us. Again, within a week, the recording of this webinar will be posted to the posted webinars section of our website. If you go to our website, www.fdot.gov/CADD, C-A-D-D, you will find on the right side of the page, as you scroll down, a section that says posted webinars. where the recording of this webinar will be posted along with a PDF copy of the Q&A. So James, if you are going to respond individually to some of these questions, that is absolutely fantastic. And the rest of them will be compiled into a PDF document for your reference. Again, thanks everyone for attending. Hope you all have a fantastic day.